of the methods, formation method of clustering, which is a partitional clustering, where we discuss algorithm like the k-means. As we said earlier, we have two main types of clustering, the partitional and the hierarchical. So partitional is just partition the data according to the number of possible clusters. As we can see in the k-means, the data is always grouped according to the number of k specified, and then based on the distances calculated from the remaining data points to the initial mean. This is why it is called k-means, for example. And then for the hierarchical clustering, which is the clustering method, actually that which is a tree-like structure with the data, for example, in the agglomerative, which is one of the major hierarchical approach, which I believe we have seen how to cluster the data during our lab session this week. So this is always starting with each point to be as a single cluster, and then keep on merging the clusters up to the time when there is only single cluster, which is serving as a termination criteria for that algorithm. So today, inshallah, we are going to cover that aspect, that is to discuss the hierarchical clustering, even though we have done a lab exercise on hierarchical clustering, so maybe you will find it very easy and straightforward to understand the concept. So I think we have discussed this kind of, remember this diagram in the dendrogram that we can see in the tree when we visualize a tree, when we develop the cluster model. So cluster algorithm usually produces a set of nested clusters. We say nested clusters. These nested clusters are organized in the form of hierarchical tree. So that is one inside the other. So whenever we have a group of data or data points that are partitioned according to this particular method, so it's what we call the hierarchical clustering, because it gives us a tree-like structure in decomposing decomposing the data. So if a particular point is beginning to be an initial point, so all data points actually be broken down using that particular concept. So we can visualize this as a dendrogram. The dendrogram is this diagram, which is, even though it is not a histogram, but it is histogram-like. So we call it dendrogram. This dendrogram is trying to show how the partition is. So you can see it is a tree-like diagram that records the sequence of merges or splits. So in the case of agglomerative, actually it is trying to merge the clusters, or in the case of maybe another method of which is opposite to the agglomerative, maybe it will split the data. We will see different methods and we'll come to discuss it further. So the dendrogram here is trying to show you how the data is decomposed, and then how it is calculated, how it is divided or into different methods. So, and then the cycle here by the right side, you can see that the data, the splits, when we look at this one, we have the top. This is why agglomerative is called bottom up. Actually starting from the single data points, connecting them together based on their closeness, then up to the where we have all the data points connected. So it is similar to the dendrogram here in the left-hand side. You see 1 and 3 connected to form one cluster here. At the beginning, each point here is a cluster on its own. 1 is a cluster, 3 is a cluster, 2, 5, and so continuously 1 and 3, because they are closeness, they are connected to form one cluster. 2 and 5, because of their closeness based on the dissimilarity calculation, maybe using the Euclidean distance. So if the Euclidean distance is minimized, then they will form a cluster. Then finally 2 and 5 connected with 4, which is cluster, because if 2 and 5 are connected, it forms a cluster like here. Then which data point is closer to them, then it is connected also to form another cluster. And then if these 2, 5, and 4, and 1 and 3 are connected together, is there any data point which is 6 here is also connected to them. So finally, you see that we have one single cluster. So this is how the hierarchical clustering algorithm is working in either merging or splitting the data set. And then in doing that, it uses what is called a distance matrix. This is a matrix, actually, I think we have discussed the distance matrix before. So the matrix keeps up updating based on the certain criteria of clustering. And then the methods do not require the number of clusters k, because as we said, in the case of additional clustering, where we use the example of k-means, we always require a k input. That is the initial value of k. So if we say k equals to 2, that means we need 2 clusters. But in the case of hierarchical method, actually, there is no need for any value of k, but needs what is called a termination condition. This is why I told you, if it started with the initial points as a cluster, keep on connecting the closest point up to where all the data points are in one cluster. That means the termination has to terminate there. So this is why actually hierarchical always requires a termination condition. So when it starts splitting or when it starts merging, it will reach to the point where all data points are merged. That is in the case of agglomerative, which is called Agnes. For if it is divisive, which is called Diana, divisive analysis. So now it starts splitting from the top down up to the level where all single data point is a cluster on its own. So this is the two methods. So we will look at this diagram for the Agnes, which is agglomerative, which is the one that we use in our lab exercise. So it starts with this initial step. This initial step here, step 0, you see each individual data is a cluster on its own. A, B, C, D, and E. So if A, B, C, D, and E are the data points, using agglomerative, they are represented as what? At a single and as a cluster on their own. So for them to form another cluster, the closest points, looking at the point, the distances A and B are closer. So that means A and B are going to be connected. Closeness based on the distance function. So all the distances are going to be calculated using maybe the Euclidean distance, Manhattan distance, or whatever. So now, if A and B are closest, then they will be merged to form one cluster. So at step 2, you can see that they form a cluster now, A and B. So if A and B form a cluster, then another data will be data values also has to be what considered to say, okay, now is there any data that has that is closer to A and B? So maybe C is closer to A and B now. C, D, E form a cluster. So down here, before C, D, E can form a cluster, you see D and E are close, then they form one cluster again. So C is closer to D and E, then they form one cluster again, C, D, E, and C, D, E. So finally, A, B, and C, D, and E are becoming so close based on the calculation of the distance function. So finally, we have a single cluster where all the data values A, B, C, D, and E are inside one cluster. So this is how the agglomerative is working. This is why it is called bottom-up approach. Okay, so this in contrast to the agglomerative divisive, which is a divisive analysis called Diana, it is opposite to the Agnes, which is actually top bottom approach. So now it is starting with the top where we have the single cluster here, where we have A, B, C, D. So now it starts splitting. This is why we say either split or merge. In the case of agglomerative, it is merging the clusters. In the case of divisive, Diana, it is what? It is splitting. So now from top, we have A, B, C, D completely. Then down, we have C and D and E forming one cluster, A and B forming another cluster. Coming down, we have D and E forming another cluster. So finally, we have A, C, D, and E as individual clusters. So this is why you see the arrows showing the process, how the process of clustering is taking place in these two different methods. So the explanation is here. This is the agglomerative and divisive method. Start with the agglomerative, as I said earlier, start with the points. as an individual clusters. At each step, it merges the closest pair of clusters until only one cluster or k clusters left, as we can see in the diagram. Or for the diffusive, actually it starts with one all-inclusive cluster, as we can see here. A, B, C, D, E is all-inclusive in one cluster. So now at each step, it is split. This is why I told you, if it is Diana, it is splitting. If it is agglomerative, it is what? Merging the clusters, because it starts with a single to merge them to the whole. While this one starts with the whole cluster, splitting them into the single cluster. So until each of the places contain one point. So that is it. So the traditional hierarchical algorithm use similarity or distance matrix, that is to merge or either split one cluster at a time. So this is the example. This is a process of like hierarchical clustering as introduced by Kaufman and Rossi in 1999. So this method is implemented in statistical package like S+. Actually, they use this method of clustering. But traditional method usually use a single link method and the similarity matrix to update the matrix so that can be keep on merging the cluster, because the similarity matrix can help in merging or splitting actually. So this is why similarity matrix is very important in clustering method, especially using Agnes or Diana method. So it merge nodes that have the least dissimilarity here continuously, the one with the minimum Euclidean distance. If A and B actually are closer, so their similarity is wider while they have minimum Euclidean distance. This minimum Euclidean distance is giving them least similarity. That is, they are more similar. If they have least similarity, that means they have what? Closeness in their what? Euclidean distance. So it go on in non-descending fashion until all they eventually all nodes belong to one or to the same cluster. So you can see it in the diagram here. It started with the was connecting the different data points. We have different data points here. In the second step, you can see them connected to form a cluster. In the third step, you can see them forming only two clusters. So continuously, this is how the algorithm is working. So here is the pseudocode of the algorithm for agglomerative clustering method, which is a more popular clustering technique being used. Actually, this is why even in Weka, it is programmed to use agglomerative approach. For the algorithm, we'll start with computing the dissimilarity matrix, because it is from the dissimilarity matrix that actually it will be picking the one that have the closest similarity or less dissimilarities actually. So now the first step of the algorithm is to compute the dissimilarity matrix. And then when it computes the dissimilarity matrix now, it will let each data point to be a cluster. If, as we can see, we can remember the last, the previous slides where we have the Agnes process, A, B, C, D, E are started as what? At individual clusters. And then this is the beginning of what? Like the initial initialization of the algorithm. So in step 3, we'll start repeating. That is merging. We merge A and B to form A, B, one cluster where we have A and B. To merge D and E to have one cluster where we have D and E. So merge the two closest clusters and then update the similarity matrix. Then merge another clusters, update the similarity matrix. So at each step, the similarity matrix is being updated as a table. So finally, you see that all only one single cluster remains. That is, we have A, B, C, and D, O, and E in one single cluster. So this is a simple process or pseudocode of this algorithm. It's very straightforward. And then the key operation is the computation of the similarity of two clusters, which is very important actually. In clustering, always deal with the similarity. This is why the initial step told you there are similarities, either the intra and then inter cluster similarities. So this is what determines how the match or how the split of the clusters can be done in the algorithm. So different approaches may define different distances between clusters. Yes, maybe using the Euclidean distance, you can see that the method of calculating the distances is different. Using the Manhattan is different. Using the Minkowski maybe is different. All this. So there are a lot of methods of calculating the similarity. But the bottom line is that it's the most important operation or key operation in clustering, because the similarity is not calculated, so definitely you cannot have the closest clusters to match. So as we said earlier, we see the dendrogram is used to visualize the data and see where at each point you have the cluster. So you look at this dendrogram diagram, all this that we have on the bottom here, we have the data points. All these are the data points. At this point, all of them are individual clusters they are on before they can even be matched. So each data point is a cluster on its own in the initial step. If you refer back to the algorithm, and then so this dendrogram is trying to show the cluster match. So it's the composed data object into several levels of nested partitions, which is a tree of clusters called a dendrogram. So you can see nested of clusters. You see 1 and 2 here. Point A, 1 and 2 is connected to form a cluster. Point 1 and 2 and 3 is forming another cluster. So at the other side, you see point here, the last 2 points forming a cluster. The last 2 points connecting with this. Now here we see another point at the middle forming a cluster. So finally, all the clusters, all the points are connected using the central cluster here. So a clustering of data object is obtained by cutting the dendrogram at the desired level. Then each connected component forms a cluster. For example, here we say these 2 data points, we can cut it here. So when we cut it, then this is a cluster. When we cut it top here, it's a cluster also. Then anywhere that you see, you can cut, you can what? Create a cluster there, from there. So this is why, as I said, sometimes we use clustering in the pre-processing step, sometimes or in data reduction. So in data reduction, we use clustering to reduce the size of the data. For example, now we have all this data, we have already imagined. Now we can code it at any point here. When we code it, maybe it is the data that we need. If these are the prices, for example, down here, we have prices 100 RM to 200 RM to 300 to 400 RM continuously. So if our interest is 100 to 200 RM, we just code this one and then remove all the remaining data from our data set. That means the size of the data is reducing. So this is how the clustering is being done. I believe you have seen the dendrogram when we visualize a tree during our lab exercise. So this is the situation, how the situation is starting. See, you can see it here. Start with the clusters of individual points and the dissimilarity matrix. So this is the example of the dissimilarity matrix. So these are the data points. We have P1, P2, P3, P4 continuously up to P12. So you look at this, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 data points. So these data points actually can form a matrix. We have 12 here on top, we have 12 here down. So they are going to compute the similarity of these values, which we have done in in our previous lecture. So maybe what's the distance between P1 and P2? We take this one to be our P1 and P2. What is the distance? Sometimes P1 and P1 is always 0 because it's the same cluster, because we say it's cluster on its own. That means we cannot say that it's distance from this cluster to this cluster. But for P1 to P2, yeah, we have a cluster from P2 to P3 continuously until all data points is what? We have the dissimilarities in this matrix table. So this is how the situation is working. After some margin steps, we have some clusters, for example. So we have already merged the 12 data points to form what? 5 clusters. You can see C1, C5. So if you refer back here, because if you look at them here, based on their closeness here, we have one cluster. This 3 point, we have another one cluster. This 2 point, we have another cluster. This 2 point, we have another one. And this 3 point, we have another one. So looking at the distances, now we have only 5 clusters out of these points. So you can see They're already connected. P1 and P2 is connected to form one cluster, P3 and P4 to form cluster 2, and then continuously up to where we have P10, P11, and P12 to form a cluster, and there's P9. And so continuously you have, now finally we have 5 clusters in this. So P1, P2 cluster, P3, P4, P5, P6, up to P9 we have form one cluster, and then finally 10, 11, 12 form another cluster. So this is how the matrix is being updated. And then continuously you can match also another cluster. We want to match the two closest clusters again, C2 and C5, for example, and update the matrix. So continuously, this is how the matrix keeps on updating until we come to the point where all the data points are in one single cluster. So you can see C2 and C5 is connected. So definitely next, you will see C1 connecting C2 and C5 cluster. Can you see C1, C2, and C5? So we have it there. It has to be updated in the matrix. So how do you update this matrix? Is from calculating the distance functions. So how to define intercluster? I think we have in the introductory part, we talk about inter and intracluster similarities. So intercluster, that is where we have the distances between two different clusters. So here, you can see that we have different clusters. So to define the intercluster similarity, we have many options. One of the options is minimum. Second is maximization, which is maximum. Third is grouping them to get the average. And then pause is the distance between the centroid, with the centroid point. In the case of K, where we have the centroid point. And then there are other methods driven by an objective function, so it depends on the, but this minimum is what we call the single linkage. If you remember what we did in the lab, we say we use single linkage, complete linkage, and then the average linkage. So these are the three that we use during our lab. So this represents this linkage. So how this cluster similarity is calculated is through the linkage. This is why we say hierarchical clustering, always a distance function work with the linkages. So a minimum linkage is what is considered as single linkage. We will see the explanation in the subsequent slides. So now, if you want to determine this intercluster similarity, we either use the minimum to see, okay, what's the minimum value between the last minimum point here, which is the closest point to the next cluster. So this will determine the distances. So whatever we have here, we take it as a what? As an initial point to say that, okay, this cluster is not, is going to be matched with this cluster. So that is minimum. But for the maximum, we take the maximum point, the last point in the cluster A, and then the last point in cluster B, then it will calculate the distances there. So this is how the similarity, intercluster similarity is calculated. It is either using the minimum, where it will only look at the minimum point in this cluster, and the minimum point is the second cluster, or to use the maximum, where it picks the maximum point in the cluster A, and then the maximum point in cluster B. Or it will use the average. It will group all the data points and calculate the mean, which is the average value. So it will calculate all the distances. The distance, if this we have 4 points, it has to calculate the distance between all the 3 points that we have here. This one point A, what is the distance to point B? This point A, what is the distance to point A in this cluster? And point A in cluster, what is the distance to point A in this? So this is why you see that all the 4 cluster points here has to what? The distances between them has to be calculated. Then finally, the average of the distances is going to be taken as a group average of the distances or the centroid. If in this cluster, a particular point is created to be a centroid, which determines which of the data points is going to be around that centroid. And then in another cluster B, another centroid point is determined to show which data point is, so this centroid is similar to the main point of each of the cluster here. So now the distance between these two centroids is determining the intercluster similarity between these two different clusters. Okay, And then, so now let's look at this minimum and maximum. Minimum, as I said, is what we call a single link, what we have, the one that we use in the class, in the lab, during the lab session. And the maximum is what is called a complete linkage. So we'll see how this can be work as an operation actually in determining the intercluster similarity, and to say that, okay, this cluster and this cluster are not similar. So similarity of two clusters is based on the two most similar or closest points, that is in the case of minimum or single, as I had explained earlier. So the minimum point or the closest point is going to be considered and the closest point with the different cluster. So this is determined by one pair of points, that is by one link in the dissimilarity group. So this is why we say the two most similar. If you go back here, you can see the minimum here. So you can see the two most closest points, because this one is the most closest to this particular cluster. And then this point is the most closest to this cluster. So this is why it is called minimum and or single linkage. So for the maximum, actually, this is two least similar, because in this they are least similar because they are far away. That is the most distant point in the different clusters. So this is why in the diagram you see that it points to the most distant points from the cluster 1 and cluster 2, or cluster A and cluster B. So that means it's indicating that they are at least similar. You can see the most distant, this is the most distant point in this cluster, and then another one here is the most distant point in this cluster. So this will determine the similarity or the dissimilarity in these clusters. So it is determined by all pairs of points in the two clusters. So the operator used in minimum is what is called minimum operator or minimum value operation. And then or in the maximum value, we use what is called maximum value operator or maximum value. So this I use, for example, here you can see from this data points 2 and 3 here is indicating the minimum. Can you see it here? Example here with this data point, you see 2 and we have 2, 5 and 2, 3 and 6 are different clusters. And then we have 1 here as different cluster. We have 4 here as different cluster. Since they are individual clusters, but 2 and 5 is matched to form one cluster, 3 and 6 is matched to form another cluster. So that means to determine the minimum using the minimum distance function. So, okay, now what is the distance between this cluster 3 and 6 we have here, and cluster 2 and 5 that we have here? So now we calculate the minimum distance. Say, okay, now 3 and 2, what the distance is and 2, and then distance 3 and 5, and then the distance 6 and 5. So continuously they have to find what the distance is, because we are trying to find the distance between this cluster where we have 3 and 6 and 2 and 5. That means 2 clusters. So that means the distance has to be what calculated. What is the distance between 3 and 2 here? What is the minimum distance? And what is the distance between 6 and 2 here? And then what is the distance between 3 and 5? And then what is the distance between 6 and 5? So all these points has to be considered to get the minimum. So the minimum values that we have is what is called the minimum values. This is what is only minimum operator. So out of these distances, if the distance between 3 to 2 is 0.15, for example, we will see when we come to do the example in the table. Or the distance between 6 and 2 is 0.25 because it is a bit far. Or the distance between 3 and 5 is 0.28, which is a bit far, 3 and 5. And the distance between 6 and 5, which is the farthest point, 0.39. So you see the minimum one here is 0.15. So 0.15 is going to be used to update the similarity matrix actually. So now the point is going to be used to link the next one. So you can see. So for the maximum, it is going to be the same, but in selection here, the process is the same, but in selection, it will select the maximum value to determine the distance. So you see maximum here is 0.39, which is 6 and 5, while in the minimum it takes 2 and 3. If you look at the previous one, 2 and 3 is the minimum distance, so it takes it as a minimum, with the most closest distance. But for the maximum, it will take 5 and 6, which is the worst. The 2 least similar, which is the most distant one. So 0.39 is going to be the point to be considered using the maximum operator. So this is a cluster similarity with minimum or single. Let's see, similarity of 2 clusters is based on the most, which we have already explained. So let's look at this example and see how the similarity is being calculated. So you can see we have the point, for example, these are the data points that we have, point 1, 2, 3, 4, 5, and 6. We have different data points scattered on this particular graph. So now, using X and Y here that we have, now we can create what? We can create a table based on the coordinates. So points, we say P1, P2, P3, P4, P5, and P6. So what is the S coordinate of P1? You look at the S coordinate of P1 here. This is the X down here. We have 0.4. What of the Y coordinate of P1 is 0.53. So now we say X is 0.4, Y is 0.53. What of point 2? What is S coordinate? Coming down here, we have 0.22, which is around here. And then for Y coordinate, we have 0.38, which is here, it's around this point here. So now we have the coordinates. For P3 also, what is the X coordinate? P3 is 0.3 something, 35, yes, which is in the middle here. And out of the Y coordinate, maybe 0.32. So now it is here. So for the P4, see what's the value of P4? Where do we have? We have 0.26 as a X coordinate. And then for Y coordinate, we have 0.19, which is closer to 2, 0.2. So for P5, look at where is our P5? 0.what? X coordinate, we have 0.1, 0.08, which is not up to 1. And then we have 0.41 as Y coordinate. For P6, which is here, we have 0.45 here as a point. And then for Y coordinate, we have 0.3 exactly here. So this is how the table is created for the numeric value attributes. And then the matrix is also calculated using that point. So compute the dissimilarity matrix using this Euclidean distance function. Then you can calculate the dissimilarity matrix. We substitute the values here, P1 and P2. What is the distance between P1 and P2? P1 and P2, you can use the table here. You have X and Y. Y is your X, X1 minus X2 square plus Y1 minus Y2 square. Our X1 for P1 is 0.4. Our X2 for P2 is 0.22, where we have here X1, P1, and P2. For Y, we have 0.53 and 0.38. All of them square, then we take the square root, we have 0.24. So that means here, P1 to P1, we have 0, 0. Then for P1 to P2, this is what we have calculated here, we have 0.24. So this is how all these values are calculated. So maybe you can find time at your leisure time, substitute the formula and confirm whether these values are the same. So you use these coordinates and then calculate the value. P1 to P1 definitely is 0. P2 to P2 is also 0. But now we have seen how we substitute the values to get the P1 to P2. Then we can get P1 to P3. We can get P1 to P4. Those are the values. We have already given you the values. Then you can confirm what we check when you have the leisure time to make sure that the values are the same. So after calculating the similarity, step 1 is to find two shortest distances based on the algorithm from distance similarity matrix to become the first two clusters. So we already created the similarity matrix. Now it's just to keep on updating, connecting the closest clusters. So now it's saying that find two shortest distances from the dissimilarity matrix to become the first two clusters. So what are the shortest one here? We can see that we have P3 and P6. 0.11 is the smallest one. This is why P3 and P6 is taken here as a cluster. Second one, P2 and P5, where we have 0.14, P2, P5, so the second lowest. So this is why I said, because we are talking about the minimum, so for the minimum, we take the lowest minimum values. Hope it is clear. So now we created a dendrogram to start connecting the clusters 3 and 6. P3 and P6, it is connected. I draw a line, and then what do we have as our axis here? The maximum is 0.11. So we have 0.11 here. Then connect them at 0.11. And then 0.14. Sorry. So now we have connected them. So for 2 pi, 2 and 2 and 5, now 2 and 5 is 0.14. So we connected them at 0.14. Now you have them connected. So continuously, you keep on connecting like that. Okay. So this is another example using the cycle. So you see 3 and 6 are connected to form one cluster. 2 and 5 are chosen to be another cluster. Then you can see the closest cluster is 1 is connected to form cluster number 3. And then another 2, this 1 and 2 is connected to form another cluster. And then 1 is connected and they form another cluster. Finally, 4 is connected to 5 and 2 to form another cluster. So now you have all the clusters connected. So the step 2 is to form the cluster by finding the point with the minimum distance to the other points in the existing cluster. So update the matrix with 2 newly formed clusters. So the matrix is updated now. You can see we have the P1, which is 0, 0. Now the 2 newly clusters is P25 and P36. So now we form another matrix, P1 and P25, P36, and finally P4. So now the matrix is going to be updated using this method, the same method for the single, 3 and 6, 2 and 5. Use the same method that we did previously. Get the point as 0.15, you say 25, 36, you have 0.15 as your minimum distance. 3, 6, and 1, because we have already connected 1 with 3 and 6 here. When you go back to this slide, sorry, 3, 6 connected to 1. So now we are moving to another one. Yeah, 3, 6 connected to 1. What are the distances? 3 and 6, 1 and 3 and 6, 3 and 1, and then 1 and 6. So now finally we have the smallest as 0.22. If we calculate the distance from this previous distance similarity matrix that we have. So we follow all of them up to the point where we have connected all the data points. Then we have, for the closest clusters are cluster 36 and cluster 25 with 0.15. So the clusters are matched. So finally, we are going to merge these two clusters again to form what? Can you see it here? Trying to match these 3 and 6, 2 and 5 because they are closest at 0.15. So they are connected here. So the dendrogram is showing us how this can be connected. This is step 3. So step 3 of the algorithm, form the next cluster by finding the point with the minimum distance to the other points in the existing clusters. So continuously you keep up connecting because now you have already connected cluster 2, 5, and 3, 6. So now these are your new clusters. You say, okay, now 2, 5, and 3, 6 are already connected. Then you are going to update the dissimilarity matrix. 3, 6, 2, 5 connected with what? Connected with 4. If you go back to your previous slide where we have the ovals connecting them, now you have these values, and then distances between these will give you what is the maximum between from the values that we have previously. We have 0.16 and 0.20. So the minimum is 0.16. And then for 3, 6, 2, 5 connecting 1, then we have 0.22 also. So you can substitute in this table. You can take the points and put them in your table so that you have the connection that you have with the values. So the matrix is updated now. And you see we have 0.22, 0.16, and 0.37, which is P1 to P4, which is already in the table. So the dendrogram is here. So 3625 already connected at 0.15. Now 4 is going to be connected at what? At 0.36. Okay, 0.1516, sorry, at 0.16 we are going to connect this. So now 0.16 is here, around here, you connect P4 with it. Can you see? 2536 already connected, then you connect them with what? With 4 at 0.16 value, which is a minimum. So continuously, the last point that we have is 1. So you see how the last one, how can we connect 1? These 3 clusters, the new cluster we have is 2, 5, 3, 6, and 4 already connected to it. So now we calculate the similarity using the one we are merging data point 1 also. So you see minimum distance. So finally we have 0.22. Then we update the matrix. So we want to connect this data value to P1, to our data point 1. So at 0.22. So now we see why do we have 0.22 here? Around here, 1 is connected. So you can see all the data points are now what? Becoming one single cluster using the agglomerative method. So you can see from here, final matrix, we have no remaining data point, or we have 0 here. This is what you call a termination. It terminates here because it satisfies the termination condition, since there is no other cluster required to be matched. I hope it is clear. Do you have any question on the single link?
Yes, sir.
Yes. No question? You want to ask question?
No question, sir.
Okay, alhamdulillah. So now moving to the next one, still you can see how the nested method is being connected. Just other clarification using the nested clusters. Can you see it? So can you see how it is being connected? Finally to become one single cluster. Okay. So to 5.2 and 5 connected, 3 and 6 connected. We have 1 and 2 clusters. Then 3 and 6, 2 and 5 are connected to form cluster number 3. The cluster number 3 is connected with 4 to form a cluster number 4, and finally 1 is also connected. So you can see that the diagram is all the same. We'll give you the highlight of how this connection is being made. So what are the maximum? Well, we have seen how the single linkage, which is minimum linkage, is working. So similarity of 2 clusters in this particular linkage type is based on the 2 least similar. When we say least similar, the most distant ones, which as we explained earlier, the most distant point in different clusters. We have cluster A and B. So what are the most distant point? Because the previous example using minimum or single is the what? The most similar closest point. But this one is the most distant point. So now it's determined by all pairs of points in the 2 clusters. So now calculation is using the maximum, but selection to match is based on the minimum. So this one has one important thing to understand. If you look at the previous one, the calculation is using the minimum, and then also the selection is using the minimum. So, but here the calculation is to use the maximum, which is the maximum linkage, but the selection is still the same in selecting the values to peel out to update the cluster. The matrix is the same thing as the previous one in the single linkage. So it's only in the calculation that they differ. We are always calculating using the maximum value, but in the previous one we calculate using the minimum value, the values that are so closest. But here the values that are what? Most distant. But in the selection to update the matrix, it uses the minimum as in the case of previous one. So that is one thing. So it's here The selection is going to be the same because we say the selection is based on this minimum. So you can see it is as in the case of previous one, minimum points where we have P3 and P6 as a one cluster, P2 and P5 as another cluster, almost the same with the previous one. Even the connection here is the same. And then with update of matrix, this is where the maximum is selected. You can see we update the matrix here. Instead of selecting the minimum value 0.15, 0.39 is selected to be what? The maximum. This is what you are saying. The calculation is based on the maximum, or the selection in updating the matrix, where it's going to be based on the minimum. So always maximum is selected and update the matrix to the maximum, but the selection in connection, then we take the smallest value or the minimum value. So almost the same process, but only that the maximum is being selected in updating the matrix. You can see 0.39 is selected for 3625 instead of 15. 0.23 is selected for this 36 and 1, and 0.22 is selected for 36 and B4, and then 0.34 is selected as the maximum for 25 and 1, and then finally this one is selected. So now the question is, form the next cluster by finding the point with the minimum distance to the other point in the existing cluster. So when the matrix is updated, so in selecting the newly formed part cluster, the minimum one is going to be selected as in the case of previous one. So this is why you see 0.22 is selected here, because in the matrix 0.22 is a minimum value. So 36 is going to be connected with 4. So maybe the dendrogram here is going to be a bit different. You can see 36 cluster is connected with 4 because 36 and 4 here is a minimum value at 0.22. It is connected at the point 0 and 0.22. And then 2 and 5 is already there, but you can see 1 in the center. So now the matrix is updated using the maximum value. So now we have step 3 where we find the point with the minimum distance again, 2, 5, and 1. So where we have the minimum 5 distance, 2, 5, and 1, 0.34 is the minimum, then it is connected also with the value. So as I said earlier, the only difference is where you are going to select, well, in the calculation, in the updating the matrix, the calculation, you use the maximum value. But in the connection, minimum is going to be P again. So sometimes you can see that the dendrogram may give you different dendrograms. You can see this one, 3, 6, 4, 1 in the middle, and then 2 and 5 in the side. So depending, whenever you are asked to use maximum or complete, so it's only in the calculation. Updating the matrix, always pick the maximum value. But if it is single linkage or minimum, in updating the matrix, always pick the minimum value. But when it comes to the connecting the clusters, minimum value is going to be used in both cases to connect the clusters. So this is why we have these values. So finally, we have all the connections, and then the termination criteria is satisfied because all the data points are linked. So then it will terminate. So this is the example. Maybe you can see even this example is different because you see 3 and 6 is connected. 2 and 5, we have the 2 closest clusters here. So you can see 4 is connected here because it depicts this one. And then next, these 2 are connected, unlike the previous one. And then finally, all of them are what? Connected. So you see how the nested clusters and the diagram is look alike. Maybe you can see a little bit difference in the diagrams, which you can see single link here or minimum. Do you see the starting point almost the same? Next, second cluster almost the same. The root of the next connection. Can you see the next connection to form the cluster 3 in the single link? Can you see the next connection in the maximum link to form cluster 3? Pause. Can you see? Pause. Can you see? So now the only difference is where you are what? Selection. The selection is always minimum, but the calculation is maximum here. So this is why it is called maximum or complete link. So you can see even the dendrogram is a bit different. This is why even when we look at the tree, or when visualize the tree during our lab session, you can see that, as I told you, there are a bit differences in the dendrogram. So because the linkages type differs. So this is what to make them to be different. Actually, is from the calculation of updating the matrix. So all this is a process that this algorithm is doing, and this is what we have shown you using the Weka. And then this is how the algorithm is working to link data to either match or split the data. So in summary, actually, cluster analysis use, as we can say, the group of objects based on the similarity or dissimilarity, and has wider applications. As we can see, we applied even in the pre-processing, we applied in the association rule mining, actually to group the customers. Then clustering is used actually to group different data points into different clusters. And then the most important thing is the nature of the similarity, which can be computed for various types of data, like the nominal, which we have seen previously, for the binary data, for the ordinal data, numeric and textual. All this the similarity has to be calculated, and then the distances have to be what? Established, so that the data can be grouped according to the distance or distance of the point, so data point distances. And then this we discuss different algorithms like the k-means and the hierarchical, which specifically we discuss about the agglomerative algorithm. So as I said earlier, I think maybe 1 hour is enough for us to cover to finish this. So now we still have time. So if you have questions, please feel free to ask your question, please. We still have time. This is the last part of the clustering aspect. So if you have any question on the clustering methods, then you can ask, please.
So far, no questions, sir.
So well understood.
Yes.
That's good. So make sure that when you go back home, maybe you try this simple calculation to see how the the matrix is updated here. Yeah, all this, you follow it, especially from the beginning. Let me see. Beginning of the point where we created the value. Maybe here. Maybe you can follow this example. This one. Maybe you can try and see that, okay, now the table is here. So I have shown you to using the formula how this can be calculated. So follow the same method and confirm whether all these points are the same and similar. Okay. And then revise the symbol and the minimum linkage. As I said earlier, the process is the same. It's only in the calculation here. You see that if it is a single linkage, then we pick the minimum value. Or if it is maximum, if it is the maximum or complete, we choose the maximum value like 0.39. So this is the only difference. But in connecting the clusters, always the minimum value is taken. So if you don't have any question, I think I can allow you here. We still have 1 hour until you can go and rest. So till we meet next week, inshallah. But for your information, I think your test 2 is going to be shifted to week 10, because according to the SOW, it's supposed to take place next week, right?
Yes.
So now I think based on our discussion with RP, it is shifted to, since we have already shifted test 1. So this second one also is going to be, it's going to take place in week 10. So next week, we are going to have our discussions. Maybe during the lab session, we are going to discuss the project. So make sure you have a very good progress in your project, because I'm going to receive progress from you and discuss if there is anything to suggest for you, then we'll discuss it according to your groups, right?
Okay, Doctor.
Yeah, that's good. For this, according to this, actually, we're supposed to have test in week 9 next week. So now it is moving to week 10. So the activity that we're supposed to have in week 10, we are going to move it back to have it next week, inshallah, during the lab session. But our lecture is going to hold, inshallah, I think, yeah. So we have done with the clustering. So week 9 is supposed to give you time for the test. So maybe we are going to discuss association rule during the lecture session next week. And during the tutorial session, we are going to discuss the project, right?
Sir,
Yes.
for the second test, is it via online also?
Yeah, the same, the way you do the first one.
Oh, okay. All right, sir.
Yeah, but it's strictly based on the pre-processing, classification, and evaluation. Clustering is not part. It's not going to be part of the test. We expect clustering maybe in your final exam, right? So make sure you know how to do all these calculations of and then how to design, how to draw the dendrogram and all that things. They are very important. Okay. So any other question?
No
So
question,
next,
sir.
okay, so next week, inshallah, whatever activity we have in week 10, we are going to have it in week 9, inshallah, next week. So make sure you have a good progress in your project. I'm very much concerned about the project because it's a project that is supporting your marks. So make sure you have a good progress by next week so that we discuss it, because the time is going. Immediately after your test, you are going for another semester break. So after the semester break, then you are going to have, so maybe we will allow this one lecture to be after the semester break, this current trend. So we'll be able maybe to discuss our association of mining. Even though maybe the second part of the association should be shifted because of the test. So anyway, alhamdulillah, if you don't have any question, I think we can stop here. Inshallah, to next week for the first group on Tuesday, and then for the second group on Thursday for the continuation of our lab exercise. Okay. Jumpa lagi.
Thank you,
sir.
Thank
you,
you.
Doctor.
Thank you, sir.
Make
Thank
sure
you,
you
sir.
make sure you sign attendance in your future.
Thank you, sir.
Okay, Doctor.